directly do that, or is it okay to give a mock interview, or it can be a general class? No problem. Let me know what do you think.
You can continue the quantum, man.
Okay.
Yes.
So I am going to ask you some questions. So from the
Yes.
previous class, we discussed about wave function. So what is wave function? Can you tell me?
So wave function is just like the partition function in statistics. It tells about the position at a particular time and other parameters also. So, but this wave function physically has no meaning. But if we square it, the it has a probabilistic meaning. It gives us the probability of a particle in a particular space in a region. That's it.
So you mentioned about partition function. What is that?
Actually, I just made an analogy, like just partition function is this how the function is distributes the number of particle in the states. So it's a huge parameter in this statistics. Just like that, wave function is a parameter that is quite significant in quantum mechanics.
Um, I don't know, but the analogy is not very similar.
Yes, yes, ma'am. I shouldn't
So
have used that actually.
yes.
Yes.
Last time I discussed what is partition function, so I'm searching for the PDF right now. But you can directly, sorry, wave function. But you can always say that wave function is a function where in classical mechanics we talk about the position and coordinate of the particle. So in quantum mechanics, instead of particle like a real particle, we associate a wave with that particle, so which is named as wave function. So it's a mathematical description of the quantum uh, uh, state of an isolated system or of an isolated quantum system, or it could be uh, like if the number of particles are more, then the overall wave function is the overall like the quantum state of the system. That is the wave function. So you
Okay.
can directly correlate with the classical mechanics. That for classical mechanics, we don't have matter wave. We have a matter or we have a particle which has x or coordinate in the Cartesian geometry. And if it is dynamic, then we associate p as a time. But here is a matter wave, so we relate with a matter, we relate the matter with a wave, which is named as wave function, which is a quantum state, and of course it has no physical meaning. We can only have the mod square value, which is the probability of finding the particle in space should be always 1. Here is a particle. Okay,
Yes, ma'am.
so let me see also other if there are any other things. Okay, last time we also discussed about the conditions for a valid wave function. So can
Yes,
you
ma'am.
tell me what were the conditions?
The conditions are the wave function should be finite, continuous, and the derivative of the wave function should also be finite and continuous. And it should not be sharp in the plot.
Okay. So
Yes.
first you told me wave function should be single valid and finite.
Yes, yes.
So what is the physical meaning? If it is not single valid, then what will happen?
If it has multiple values, uh, like in the case of mod of sin x, it has multiple values. so it is not applicable.
Yes, why? The physical meaning, like if it has multiple values, then what will happen physically?
It signifies that the particle is present everywhere, so that doesn't match in the practical experiment, because particle is only at one particular point.
Not everywhere, it's like multiple locations where it is multiple values.
Yes, yes.
If it is not continuous, then
It is discontinuous, then there exists some gap between the plot.
yes, that is, no, discontinuous means gap.
Hmm.
What will happen if there is discontinuous? Physically, what is the meaning?
Physically, the
There
particle
is a
exists.
discontinuity. Mhm.
Yes, yes. Is my voice audible?
Yes. You understand the question, right?
Yes, ma'am.
Okay. So, what do you think?
Actually, physical significance, I don't know.
Okay, no problem.
If,
So,
okay.
let's say we have a discontinuous wave function. Okay, a discontinuous function which we describe it as a wave
Yes.
function of a matter wave. And so, for example, if there is a discontinuous wave function, we can give like it is like a step function or something like has a discontinuity. Okay,
Yes. Yes.
and
Hmm.
if you take the first derivative of the wave function, then you will get infinite derivative, right? At the discontinuity.
Yes, ma'am.
And if we relate this first order derivative, z or del of psi,
Hmm.
what does it represent? Which operator we associate with del of psi?
Or to the step function,
No, this del means the first derivative,
momentum.
psi is the wave function, yes,
Momentum.
momentum. Now del of psi becomes infinite means momentum is infinite,
Yes, ma'am.
which is not possible.
Yes, yes.
That's why for a physically realistic system, you always have a continuous wave function. Any discontinuity will lead to infinite first derivative. And this we know that the operator, momentum operator, is expressed as the minus IH cross grad of psi. And now, or del psi del x plus del psi, whatever you like, if you want to uh, express it in one dimension. The first order derivative of psi. So if that is infinite means particle has infinite momentum.
Okay.
It's not acceptable. What is the other condition?
Uh, the derivative of psi should be finite and continuous, and the
Hmm.
psi should be finite and continuous.
The derivative of psi should be finite and continuous. Why? What
Yes, ma'am.
will occur? Is there any problem if it is not?
if the
Yes. So if the first order derivative is not continuous, what will be the problem in the wave function? Like why it is not acceptable? Sanjay, you can also answer the question. Question is that if the first order derivative or derivative of wave function is not finite and continuous, then why it is what is the problem? Why the condition that happens like the derivative should be continuous? What is the reason?
if psi becomes infinite, we cannot find the particle in that particular region, right?
How psi becomes infinite?
If x tends to infinite, in case of e raised to x, if we take psi as a function of e raised to x, the the function and the derivative of that function tends to infinite. So this is not valid.
Let's focus on derivative. Okay. Psi
Yes,
tends to infinite. That is another condition. So let's not focus on psi right now. Just focus on the derivative part. So
yes,
if the derivative is not continuous, then what is the problem? You think wave function are not acceptable. Yes, we know
yes, yes,
that for if the wave function is the first derivative of the wave function is not continuous, the wave function is not acceptable. That we know. The question is that what physically it means. Or what will happen? Like you can have the same analogy that I have given you in the previous.
yes,
What happens when we take the wave function derivative for a discontinuous wave function? The derivative becomes infinite at discontinuity, right?
yes,
And now if you have derivative is discontinuous first order derivative in the wave function, then if you take the second derivative, then you will get infinite or it will diverge at the point of discontinuity. Now, can you coordinate the second order derivative of the function with some operator? Hamiltonian. Okay, yes, energy. Right. Del to E, del to psi, del to. That is the problem. If E becomes infinite, that means that the particle has infinite amount of energy, which is not acceptable. Okay? Do you understand, Harish?
ma'am, how is Hamiltonian related to double derivative?
Hamiltonian is talking about the energy. And we know if you want to express the energy operator, how do you represent it? Total energy.
In terms IH plus dou psi by
In
dou t.
terms of psi.
एक्सप्लेन करना कि आपने क्या बोला था? हेलो मैम.
Hello. वॉइस तुम्हारी ठीक से नहीं आ रही है।
Actually, Hamiltonian IH cross dou psi by dou Tn.
Mhm. And when you express it in terms of wave function, so if you talk about the kinetic energy plus potential energy, how do you write it? Like, it is also named as total energy exercise, right?
Yes, yes.
So how do you write it in terms of
मेरी
psi?
वॉइस आ रही है क्या?
मेरी वॉइस नहीं आ रही है?
हेलो
हेलो? Harish, can you hear
सही
me
नहीं आ रही मेरे
properly,
को.
right?
Actually, voice break हो रहा है संजय का.
संजय का वॉइस ब्रेक हो रहा है, मतलब मेरा तो आ रहा है ना ठीक से?
हाँ हाँ आ रहा है.
संजय, आप एक बार अपना कनेक्शन चेक कर लो इंटरनेट का, मे बी देयर इज सम प्रॉब्लम. There is noise outside right now from my point, but I can't do anything. But I can close the window like just 1 minute. ठीक है, तो ये हमने
मेरी
थोड़ा बहुत
वॉइस आ रही
अपना
है.
आ रही है, बट ब्रेक हो रही है तुम्हारी वॉइस, है ना?
हेलो मैम.
हेलो?
हेलो मैम.
हेलो?
हेलो मैम, अब आ रही है आवाज?
हाँ, आ रही है. ठीक है. So let me come back to the topic. So after discussing with the principle of quantum mechanics, basics of quantum mechanics, postulates of quantum mechanics, अच्छा वापस आप फर्स्ट ऑर्डर डेरिवेटिव का एक्सप्लेन करना. फर्स्ट ऑर्डर डेरिवेटिव का एक्सप्लेनेशन यही है कि जैसे हम अगर फर्स्ट ऑर्डर डेरिवेटिव को कंटिन्यूअस नहीं लेते हैं, लेट्स से इट इज नॉट कंटिन्यूअस, then if we take second derivative, right, then we will get infinite or diverging second derivative at the point of distance. Now if we want to express energy, then how do you express it? Kinetic energy and potential energy. So potential energy is not dependent on the wave function. It is outside. It is external.
मैम वापस
But
ज्वाइन
the
करता हूँ
kinetic
काट के.
energy, hello,
हेलो मैम.
you can, I think you can check the recording, and it should be like this, like proper. ठीक है? So the total energy, overall the energy of the particle
मैम
is divergent.
आपकी आवाज तो आ
Therefore,
रही है एकदम.
आई थिंक संजय तुम्हारे वजह से प्रॉब्लम है. हरीश तुम्हें सुनाई दे रहा है ना ठीक ठाक?
Yes, ma'am.
ठीक है, तो हम कंटिन्यू करते हैं.
मेरी वॉइस आ रही
अदरवाइज
है?
हाँ आ रही है, पण ब्रेक हो रही है थोड़ी.
I'm not going to make it longer because we have to finish a lot of topics. So, for example, I am sharing my screen. So, if we have a potential, let's say once we do understand the time evaluation system, symmetries, there are a lot of things after postulate of quantum mechanics. So you can follow any of the book. I follow like Griffith because I see there are a lot of examples also. But and also Jetli I follow because of the precise, everything is written precisely. So this is Jetli, and if we go about if we see the topics here, so uncertainty relationship, time evaluation operator, stationary states, Schrodinger equation and wave packets, conservation of probability, time evaluation of expectation values, symmetries and conservation laws that we know for any of the we have like symmetric quantities, we have associated conservation laws, and also connecting the quantum mechanics with classical mechanics using Poisson bracket and or Poisson bracket that usually n is not pronounced and commutators, Arnfest theorem, quantum mechanics and classical mechanics analogy. So please read all these topics one by one and understand the basic physics and the pillar of quantum mechanics and the analogy between the classical mechanics and quantum mechanics. And other major topic which in the interview you will be discussed or you will be asked is the one-dimensional problem. So you will be asked to draw the wave function for different wave functions, different potentials. Okay, so this is a very important topic, and the interviewer can ask you any of the wave potential. So right now I am going to ask you or draw the wave functions for different potentials. Let me just check there. Okay. So please draw wave function for a for a potential state, not for a free particle, for a state potential, and send it in the group.
Step potential, ma'am.
Yes, state potential.
मैम आप वॉइस आ रही है मेरी?
हाँ, अभी एक क्वेश्चन पूछा है मैंने, स्टेप पोटेंशियल के लिए वेव फंक्शन ड्रॉ करना।
ई ग्रेटर और ई लेस देन वी उसका
स्टेप पोटेंशियल में कैसा रहेगा वेव फंक्शन? E is, let's say we take the potential is greater than the total energy of the particle. Is less than. Okay. तो दोनों के लिए करो, E लेस देन V के लिए भी और E ग्रेटर देन V के लिए।
मैम मेरे पास अभी कोई अस्त्र शस्त्र नहीं है।
अच्छा, हमारा इंटरव्यू कैसा हुआ?
हाँ बढ़िया गया मैम।
क्या अभी डिस्कस करते हैं क्लास के बाद और ठीक है?
ओके मैम। मैम मेरे को ये रिकॉर्डिंग लिंक भेज देना आप, है ना?
हाँ, रिकॉर्डिंग लिंक मैं तुम्हें भेज दूंगी। कोई एक्चुअली मुझे ये भी पूछना था, जैसे कि क्वेश्चन तुम्हें पूछा गया है उसमें से कोई डाउट है या कोई क्वेश्चन शेयर करना चाहोगे?
ना, जो क्वेश्चन पूछे थे आई थिंक एकदम नॉर्मल क्वेश्चन थे, कोई ऐसा क्वेश्चन नहीं था जो डाउट हो उसमें। नॉर्मली बेस ऑफ क्वेश्चन थे, दो चार ग्राफ लोड करवाए गए थे, एक तो मोडक्स का, साइन मोडक्स का,
हम्म,
साइन साइन एक्स अपॉन एक्स का, e
हम्म,
की पावर माइनस एक्स स्क्वायर के ये ग्राफ लोड करवाए।
हम्म,
एंड डिफरेंस वो कंडेंस मैटर फिजिक्स के अंदर पूछा था कि क्रिस्टलाइन एंड नॉन क्रिस्टलाइन सॉलिड के बारे में, ये क्या होते हैं। और फिर उसके अंदर दो वो जैसे डायमंड और ग्रेफिन के बीच के अंदर पूछा डिफरेंस क्या है, कि ग्रेफिन के अंदर इसकी कौन सी मिस्टेक की गई थी कि उसको जहाँ वो वांडरवाल बॉन्डिंग बन रही थी वो उनके बारे में पूछा था, दोनों के बीच के डिफरेंस। नॉर्मल ऐसा
डायमंड
कोई
एंड
हार्ड नहीं।
ग्राफिन में दोनों के बीच में फोर्स का डिफरेंस या
ना
स्ट्रक्चर
ना,
डिफरेंस
दोनों का
में
डिफरेंस
difference?
क्या था कि भाई ग्रेफिन में क्या डिफरेंस था, और जो डायमंड की स्ट्रक्चर बन रही थी ना उसमें क्या डिफरेंस था, एक वो कोवेलेंट बॉन्ड
स्ट्रक्चरल
बना रहा
डिफरेंस।
था, इसके अंदर मैंने तो ये बोला था इसमें कोवेलेंट बॉन्ड बन रहा है, उसके अंदर वांडरवॉल बॉन्ड बन रहे थे, ये इंसुलेटर की तरह बिहेव करता है, वो कंडक्टर की तरह बिहेव करता है, क्योंकि उसके अंदर वन फ्री इलेक्ट्रॉन रहता है ना। तो ये दो डिफरेंस
डायमंड
बताए।
एंड ग्राफाइट, राइट?
हाँ हाँ,
ओके।
ये पूछा था। और एक दो क्वेश्चन हुए थे वो स्टीरियस लूप वगैरह के हुए थे, एक दो क्वेश्चन। फेरोमैग्नेटिज्म में अपन पढ़ते हैं ना स्टीरियस लूप,
अच्छा,
एमएच का रूल।
हिस्टैरिसीस। ओके,
हाँ
वो बता दिया।
हाँ, ये जो पूछे थे वो तो मैं सारा बताया उनको।
और
100 ऑफ
इसका
100।
रिजल्ट कब आएगा?
रिजल्ट इसका उन्होंने बोला नवंबर लास्ट तक, यानी कि लास्ट वीक के अंदर आ जाएगा इसका। ऐसा बोला तो है, अब देखते हैं क्या होता है।
कौन सा इंस्टीट्यूट का था?
वंदना।
गांधीनगर का।
हेलो।
IIT गांधीनगर का था ब्रो।
अच्छा अच्छा।
हम्म।
वंदना भी दी थी क्या?
हाँ, उसका भी दिया था, वहाँ पहले टेस्ट हुआ था, उसके बाद में इंटरव्यू हुआ था मैं।
टेस्ट में क्या था, कैसा था? टेस्ट कैसा था, क्वेश्चंस?
टेस्ट बढ़िया लेवल का पेपर सेट किया था उन्होंने, एकदम ऐसा भी नहीं था, वो उन्होंने दिया था MCQ का दिया था सारा का सारा, यानी कि दो ऑप्शन भी करेक्ट हो सकते हैं, तीन भी हो सकते हैं, मल्टी सिलेक्टिव क्वेश्चन वाला था।
ओके।
मल्टी सिलेक्टिव देते ही पेपर हार्ड हो जाता है ऑटोमेटिक ही।
हम्म।
ठीक था पेपर का, लेवल भी ठीक था।
और पूछे कि तुम कुछ प्रिपेयर करके आए हो या डायरेक्टली उन्होंने पूछा? स्टार्टिंग में क्या पूछा?
क्या मैं
स्टार्टिंग में कुछ पूछा, तुम्हारा इंट्रोडक्शन या क्या प्रिपेयर करके आए
हाँ,
हो?
इंट्रो था, फिर उन्होंने बोला कि क्या, यानी कि क्या इंटरेस्ट इंटरेस्ट ऑफ फील्ड बताओ पहले। तो इंटरेस्ट ऑफ फील्ड के अंदर मैंने कंडेंस मैटर फिजिक्स बताया था, फिर मैंने ये बोला था कि ऐसा नहीं है मेरे को कंडेंस मैटर फिजिक्स के अंदर ही करना है, मैं अदर फील्ड के अंदर भी एक्सप्लोर करना चाहूंगा, जैसा आपने बोला था मेरे को। तो
हम्म।
मैंने अदर बुक का जैसे वो नाम दिया था कि क्वांटम बेसिक न्यूक्लियर फिजिक्स एंड मॉलिक्यूलर एंड कंडेंस्ड, चार बुक रेफरेंस दी थी मैंने उनको। तो फिर उन्होंने लगभग मेरे कंडेंस से ही पूछा और मैथमेटिक्स के कुछ ग्राफ ड्रॉ करवाए।
ठीक।
ये बात।
ओके, तो अभी हमारा नेक्स्ट इंटरव्यू कब है?
क्या मैम?
नेक्स्ट इंटरव्यू कब है और कहाँ है? कुछ डेट आया है?
नेक्स्ट इंटरव्यू रुड़की का ही होगा। इस आई थिंक मेरे हिसाब से हो जाएगा, अगले वीक के अंदर दे देंगे।
रुड़की का तो आ गया ना हरीश?
हाँ, एक्चुअली साइट पे है बट जीमेल पे नहीं आया। मैंने एक्चुअली उनका
साइट
साइट
पे आ
देखा,
गया है।
2 और 3
नैनो टेक्नोलॉजी का आया होगा।
हाँ,
कौन से डिपार्टमेंट का
क्या
है?
हुआ?
अलग अलग आता है मैम उनका।
नहीं नहीं, फिजिक्स का सब एक साथ आया, एटॉमिक, न्यूक्लियर, हाई एनर्जी।
रुड़की का?
हाँ, मैं शेयर करता हूँ तुझे।
मेरे को शेयर करना।
ग्रुप में
लिंक
शेयर
तो
कर देना,
हाँ
तो
हाँ, ग्रुप पे कर।
पता चल जाएगा, है ना?
यस मैम।
ठीक है, अभी तुम लोग ड्रॉ करो ये स्टेट पोटेंशियल के लिए वेव फंक्शन दोनों के लिए केस में, E इज ग्रेटर देन V एंड E इज लेस देन V।
ओके।
संजय, आप भी ड्रॉ कर रहे हो? हेलो संजय। So Harish, I think there are some technical problems from Sanjay's side. But can you explain me why you have written this? Why you have drawn this?
Yes, ma'am. So basically, in the case of E, first we will focus on E greater than V region, that is right side graph. So in this, the uh, K value, that is the wave vector, we have equated to under root 2 me by h cross square. So the wave function is a linear combination of some terms. So that terms are exponential to ikx, that is sine wave. So these two wave function in the region 1 and 2, that is left and right side, are both sine wave. So here, if we plot the current density and that we get a formula that for reflection and some transmission coefficient, and from that we get a plot that is the wave widens when it enters the E less than V region in the right hand side. So it has some relation with the wavelength, that is lambda is proportional to some inversely proportional to k. So therefore we see some expansion in this wave. While in the case of E less than V in the left hand side of the graph, there we observe some decay, because uh, the we have considered a k value, that is wave vector, as under root 2m by into v minus e by h cross square. So we have considered here potential. In previous case, potential was 0. So in this, because we have considered potential, the wave function we obtain is of real value, and the real value when we plot the wave function of this, it slightly decays. So that's why we get a decay in this E less than V, and in the E greater than V, we observe some expansion.
So you told me in this case you have taken potential as zero.
Uh, no, no, in the left side.
Here potential you have taken as zero.
No, no, in the right side left part. That is
Okay.
this one.
Here,
Yes, yes,
like
yes.
for both the cases, the left region is like zero potential, and the right region you have the finite potential.
Yes, ma'am.
And the wave decreasing part is like it is oscillatory and then it decreases here or where?
Actually, I have drawn slightly wrong. The It should be near the wall.
Okay.
The decay starts from the wall.
And since there is no potential, so this is also like a shrinking of wave, or it is like you have drawn it wrong.
No, no, it is sinusoidal.
But the wave's cycle is slightly like shrink in this region. It's larger
Mhm.
and then it gets smaller, right?
Yes, yes.
So this is the error, like drawing error, or it is like this
No, no,
only.
it is not decreasing. It is the same. Actually.
Okay. Another major thing that you haven't labeled your x values here
Yes, yes,
because I don't know what is this. What
yes,
is
ma'am.
like this space described.
Yes.
So once you are instructed to draw a function for a certain potential, you have to represent your knowledge. For example, if I give you an analogy, let's say we can follow a book. What's happening? Mm. here. So let's say we are talking about the potential uh, step. So whenever you see there is a diagram, there is always like a x-axis and you have the vx, because then you will put somewhere, let's say at the x you have labeled the axis as x equals to 0 here, where the potential starts, and it goes to a like a point of v naught, or up to a magnitude of v naught. So you have proper labels. Okay.
Yes, ma'am.
So
Yes.
whenever you plot something, you should have proper labels along the x-axis, along the y-axis, and if you have like 3D, then along the z-axis also. And also you have to write down the potential itself. So first, the potential, that means V of x, let's say we just have the potential term, should be 0 for your coordinate x is less than 0 and is equals to v0 for coordinate x greater equals to 0. So this is the way of representation, and you are always being judged by the interview panel members. They will
Yes, ma'am.
always check whether you are representative enough or not, whether you are drawing everything nicely or not. Okay, so
Yes,
these things matters. Very small, minute things, but it also matters for a good impression and for a better selection, chance of selection. Okay.
yes,
And you talked about when we get Schrodinger equation, we get sinusoidal function, but it's exponential, it's oscillatory function we get. That you can tell. Okay, it's not
yes,
like
ma'am.
sine. So once you put your values and you solve the Schrodinger equation, and you will get since you have two regions, one and two, so therefore you will get two different K1 value with vectors.
Yes, ma'am.
K1, let's say, with vector associated with the wave function at the region 1, and with vector K2 belongs to the wave vector associated with the wave function at region 2. And if you have, let's say, this K1, you can write it as 2me by h per square, because you have no potential in the region 1. But since you have a potential in region 2, which is V naught, so K2 square is 2me minus V naught by h per square. And once you get the solution, you will get the solution for oscillatory, not sinusoidal. Because oscillatory is more general term, and then means that oscillatory means you have like this the that you have already drawn in this equation. And if we take this if we draw it, then we get the same thing we have drawn. And we are taking the case for e equals to v. E is greater than v naught, so therefore as a solution we get for both the wave functions they are oscillatory. And since we have this wave vector term, so E minus B naught. So if we take see K1 and if we see K2, then the magnitude of K2 will be less because of this E minus B naught term,
Yes, yes,
right? And
yes,
we know P equals to H cross K equals to H C by lambda.
yes. Inverse proportion.
So yes, inversely proportional. So it's the relation that we have already drawn. And if we also can like find out the reflection and transmission coefficient, means why we need to do that? Because we know once a wave is incident on a boundary, then at the boundary there will be reflection and there will be transmission. So therefore, the reflection, how much of the like quantity will be reflected and what is the transmission. So that's why we can find this using the values. So that and physical meaning of boundary condition, because at the boundary we know the wave function should be continuous, the derivative should be finite and continuous, wave function should be finite and continuous. So these are the boundary conditions to get a well-behaved wave function. Okay. And if we talk about potential barrier and potential well. So do you know what is the meaning of a barrier and a well?
Barrier and well. Okay.
Hmm. When it is named as potential barrier and when it is named as potential well.
Actually, I have heard the term barrier in the case of PN junction, barrier
Hmm.
junction. So, um,
So barrier means that you have
mm,
certain hindrance, right?
yes,
There is something obstacle that you cannot, like it is not
cross.
easy to penetrate or cross.
Yes,
And well means uh, it is like the just opposite. Like there is a valley or there is a well,
where the
so you
particle
can
can travel.
easily like jump into it,
Yes, yes,
right? So once you know
yes, ma'am.
that the step potential, it was a barrier because that we have drawn, it is a barrier because the wave function has to, the wave has to like cross or penetrate through it. And if we have just the opposite, if we have the potential, let's say we talk about here about the uh, boundary condition of the potential, that is v equals to v of x equals to 0 for x is less than 0 and v of x equals to 0 for x greater equals 0. And now we just inverse the situation that v of x equals to 0 for x equals to 0 and v of x equals to minus v0 for x less than equal to 0. Or we can write that v of x equals to minus v0 for x is greater than 0.
Yes,
If we take like the minus opposite magnitude, then it will become a well. Okay. So this is a very important question that you will be asked. So I am showing you the potential, which is a rectangular potential variable with function, sorry, potential form, where v of x equals to 0 for x less than 0, v of x equals to v naught for 0 to a, x between 0 to a, and v of x equals to 0 for x greater than a. Can you draw a wave function for this potential variable?
yes, ma'am.
Okay. So can you explain what you have drawn?
Yes, ma'am. In this less than this potential, sorry, I didn't name that potential. So
No
let that
problem, you can tell.
middle let that middle part be from boundary 0 to some a value, and the wave function less than 0, it is proportional to e raised to kx, because the graph is so here there is no decay possible, so we uh, just neglect that decay value and focus on this growth value e raised to kx, and this middle part where the potential is v naught from 0 to a, we have part wave function as some linear combination of exponential term, that is a sinusoidal, and in this third portion, that is greater than a region, where the potential is 0, we only select the part of decay, because in this region only decay is possible, so we neglect the growth part. So, so we have got three wave function here, and
Uh,
based on this, we
you sure you have drawn this? Because what I see here, that is more like well, not like video.
actually I have considered this potential as zero. Sorry, this in between as zero.
Can you, like, I have given you this form of potential. Can you
Yes,
write it, label it, and
yes.
then draw the wave function? Okay.
Okay.
Can you explain? Hello.
Here, hello. In the left side, the wave function is sinusoidal, and in the middle there is exists some potential v naught. So here, as we apply the wave function, the potential is considered. So if we put in k value, the graph decays, and because it's a real function, and in the right side, uh, there might exist um, there might exist the same uh, same, I think, because the wave will be transmitted, sorry, reflected. I don't think it will be transmitted fully. So maybe uh, I have a doubt regarding this right side, uh,
This
third
wave
part.
function becomes straight line here or saturated? What happens?
Uh, Maybe it remains sinusoidal, but its amplitude is not much than the first region.
Uh, you can tell that oscillatory. Don't use the term sinusoidal.
Okay, okay.
Okay, so here is a major concern. This is straight. That means that wave function is unchanged. Like it is like the it's a straight line. Like there is no oscillation. Okay,
Yes, yes,
so this is a major violation of something like which is not acceptable here itself wave function. This is a major mistake. Another
yes,
mistake that you have made, like the form is changing here, while you have no potential here. So the
yes,
oscillation should not be changing. The k vector or the lambda value should not be changing. So if you change your lambda, that means it is inside any potential. It is not free. So that is another major mistake. And here it is like going up and it's down. It should be exponentially decaying. It is not like this one that suddenly it goes up and then it comes down. That doesn't make sense. Okay?
okay, yes, ma'am.
So whole that you have to understand here why we will get oscillatory and then it is exponentially decaying and it again become oscillatory with less magnitude. And since you talked about part of the wave will be reflected, that's why the amplitude will be reduced. By
Uh,
amplitude means that the this like this width, like this height, that will be reduced.
okay,
But the oscillatory wave function will remain oscillatory here because here is also no potential. And we know
yes,
when there is no potential, the wave function is oscillatory.
yes, yes,
Okay,
yes, ma'am.
so let's check it again. So for the case E greater than V naught, we know everything is oscillatory. Only the magnitude of the wave vector will be. So, but if we have like E less than V naught, that is the tunneling case. That is major point in this discussion that I don't see the potential here properly. Let me go and check here. So function in yes. So for region one, you have this solution using the boundary condition. We will get this. So if you see here for region one, this is the psi one, and then it exponentially decreasing, and then it's again oscillatory function. Of course, it has like the lower amplitude than the first region because of the part of the wave will be reflected back from this side. Okay. Do you have any doubt in this question? Yes, Hari. Any doubt in this question? No.
Hello.
Yes, sir. Do you have any doubt in this question?
No, ma'am, it's clear.
Okay. So can you draw the wave function for is that an attractive delta potential?
Delta potential.
Attractive delta potential.
Uh, yes, ma'am. I will send it.
Can you explain it?
Yes, ma'am. At x equal to 0, the potential is basically infinity. And at x not equal to 0, it is not. The v of x is basically 0. So we solve the wave function, and the wave function comes out to be around, in terms of real wave function, exponential, e power kx and e power minus kx. So as we can see in the first region, um, the wave function is of growth pattern, because as x tends to positive value, the wave function increases in the first region, while in the second region it is of decay part, e raised to minus kx, because as x tends to positive value, it decays. So we can write it in terms of mod x.
So you were talking about this, right? The
Ye-
exponential decay.
yes, ma'am.
And but you have made like here there is no like connection between the
Uh,
waves, like it's
it
suddenly discontinuous the side.
Actually, it goes to infinity.
So this is the form is correct.
Actually,
So you can note everything, okay, and
yes.
also check everything that the everything mistakes in your like understanding that you need to cross check. And also let's draw the wave function for a box potential.
Yes. Hello.
Yes.
Yes, ma'am.
Have you shared?
Shall I
Responsible
draw
for
it
the
again?
box potential. I
Hello.
don't see the figure. Have you drawn it for box potential?
No, no.
Please draw the wave function for box potential. You know what is box potential, right?
Yes, ma'am.
Okay. Can you explain me what is your drawing?
Yes, ma'am. So uh, for the 1D box, the wave function is under root 2 by L sine n pi x by L. So for the ground state n equal to 1, the wave function is like this. The halves, and for n equal to 2, it is like sinusoidal wave, or sorry, oscillatory wave. And for n equal to 3, it has 3 loops.
But this it is x, right? Along
Yes,
this axis, and along this is y.
yes, yes. Wave
Y
function.
is psi.
It's wave function.
Wave function.
Wave function.
Are you sure along y axis it should be wave function?
Yes, ma'am.
Then where will be potential?
Sorry, ma'am.
Then how the which axis will denote potential?
Okay, okay.
So along y there should be potential, right?
Yes, yes.
And this potential leads to infinite. That is, it is box.
Oh,
Let's say the box has a dimension of 0 to L. Then in the x-axis, this part could be labeled as 0, and here it could be labeled as L. And these two boundary, they should tend to infinite because the potential here both tends to infinite, and the particle confined in a box potential. That's why the potential is a box potential. And if we solve the Schrodinger equation, we get the sinusoidal wave function. For this, there is not e to the power I k x. Here we get sine n pi x by L. Therefore, we get sine waves, and then we get nodes. And for different excited state, we get more nodes because we know the sign in this wave function. there is the n term is present, and n cannot be 0 because if n is 0, then wave function will be 0. So therefore, the n starts from 1, 2, 3. So once you have more energy, that means more nodes, which physically meaning that you have more nodes means you have less wavelength. Here the wavelength is longer compared to n equals to 3. So wavelength is less, means more energy, right? Because frequency is inversely proportional to the wavelength. Now energy increase means frequency बढ़ गया, frequency is increased. Frequency increase means wavelength is less. तो
Yes.
एनर्जी ज्यादा है इसलिए wavelength छोटा हो गया.
छोटा
So
है.
we are getting more nodes. That is the physical meaning. ठीक है?
Yes, ma'am.
Okay. So please be very very careful about the wave function and practice all the wave function. I will again in a mock interview I will ask you, and maybe in the next class I will also ask like more wave functions. So
Okay.
sketching and drawing the wave function, the probability, is very very important.
Okay.
ठीक है? तो सिमिलरली जैसे कि आपके पास अभी मैंने सिंपल वेव फंक्शंस दिया था, नेक्स्ट टाइम मैं कॉम्प्लिकेटेड वेव फंक्शन दूंगी. जैसे कि मान लो बॉक्स पोटेंशियल है, पार्टिकल एक पोटेंशियल बैरियर में है, उसके अंदर मैंने एक दूसरा बैरियर डाल दिया, तो वेव फंक्शन में क्या होगा, चेंजेस क्या हो गई, या क्या मतलब किस तरीके का शेप होगा, या सेम रहेगा, क्या रहेगा. अगर मान लो आपके पास एक पोटेंशियल वेल है और उसके अंदर आपने एक डेल्टा पोटेंशियल दे दिया, ठीक है, तो वेव फंक्शन में क्या चेंजेस होगा, क्या सेम रहेगा, हार्मोनिक ऑसिलेटर पोटेंशियल कैसा होगा, तो वेव फंक्शन कैसा रहेगा. अगर आपने एक पोटेंशियल एक वेरिएबल जो है फाइनाइट बना दिया, दूसरा वेरिएबल जो है इनफाइनाइट बना दिया, ठीक है, तो कैसा होगा. तो ये सब जो कॉम्बिनेशन ऑफ वेव फंक्शंस है वो सब मैं पूछूंगी. आपके पास अगर डबल वेल है तो कैसा वेव फंक्शन है. आपके पास अगर वन हार्मोनिक ऑसिलेटर ना होके दो हार्मोनिक ऑसिलेटर पोटेंशियल रहेगा तो वेव फंक्शन कैसा रहेगा. एंड हार्मोनिक ऑसिलेटर अगर आपका पोटेंशियल है एंड हार्मोनिक ऑसिलेटर और ऑसिलेटर पोटेंशियल, उसके केस में आपको फंक्शन का शेप कैसा रहेगा. तो ये सब क्वेश्चंस थे, मतलब इट्स लाइक मोर कॉम्प्लिकेटेड बट द लॉजिक इज सेम. वेव फंक्शन मस्ट बी फाइनाइट, must be continuous at the boundary, and also it has to obey the rules of quantum mechanics. That is Schrödinger equation. ठीक है.
Yes, ma'am.
और कोई डाउट है आज की क्लास में.
एक्चुअली कंडेंस मैटर में कौन से टॉपिक से ज्यादा फोकस करूं.
टॉपिक तो आप जैसे अगर कंडेंस में तो प्रिपेयर कर रहे हो तो बेसिक से स्टार्ट करो, बेसिक क्रिस्टलोग्राफी से, ठीक है. और जैसे कि इसमें अभी इसमें कहा समझा नहीं तो इससे एक ही क्वेश्चन पूछा था शायद, वो कार्बन और ग्राफाइट का स्ट्रक्चर डिफरेंस.
यस.
हाँ, तो पता नहीं चलेगा कि कहाँ से कब क्या पूछे. तो जो टॉपिक है सब पढ़ लो. अगर आपने कुछ बोला कि मैंने ये प्रिपेयर किया है तो दे कैन आस्क यू फ्रॉम एनीवेयर, और यू कैन लाइक डायरेक्टली स्टार्ट फ्रॉम द बेसिक, फ्रॉम द स्टार्टिंग ऑफ द बुक. कौन सा बुक फॉलो कर रहे हो.
क्वांटम के लिए.
नहीं, कंडेंस के लिए.
कंडेंस के लिए एसओपी लाई.
ओके. और एक और बुक है पूरी बब्बल की भी
विच बुक मैम.
ऑनलाइन, पूरी बब्बल.
पूरी बब्बर. ओके.
हाँ, वो ऑनलाइन अवेलेबल है. इस
ओके.
बुक को भी देख सकते हो, मतलब वो काफी छोटा बुक है, नोटबुक
ओके.
की तरह है, और उसमें कुछ कॉन्सेप्ट्स है, अच्छा है. मतलब आपको अगर जल्दी सिलेबस कवर करना है तो इस बुक को फॉलो कर सकते हो.
ओके.
सॉलिड स्टेट फिजिक्स बाय पूरी बब्बर, ठीक है.
ओके मैम.
और बाकी मेजरली जहाँ से पूछा जाता है कंडेंस मैटर में, मिलर इंडिसेस के बारे में आपसे पूछा जा सकता है, ब्रैग्स लॉ, रेसिप्रोकल लैटिस के बारे में पूछा जा सकता है, क्रोनिक ट्रेनिंग मॉडल से काफी क्वेश्चंस पूछते हैं, मतलब इट्स वेरी पॉपुलर मॉडल। तो क्रोनिक
Oh,
ट्रेनिंग मॉडल उसका बेसिक्स, फिर वहां से जो एनर्जी वैल्यूज आती है, और फिर अलाउड बैंड, फॉरबिडन बैंड, वो आपका एनर्जी लेवल प्लॉट करने के लिए बोल सकते हैं। और फिर आपका जो स्पेसिफिक हीट है लैटिस का, वो कहाँ से आता है, उसका मॉडल आपसे पूछा जा सकता है। सुपर कंडक्टर से पूछ सकते हैं, मैग्नेटिज्म से पूछ सकते हैं, जैसे हिस्टेरिसिस लूप ड्रॉ करने के लिए कह सकते हैं। और रीजन तो यही है फर्नेस मैटर का। और बाकी क्रिस्टलोग्राफी से आपसे मतलब बेसिक क्वेश्चन जैसे स्ट्रक्चरल क्वेश्चन पूछ सकते हैं, स्ट्रक्चर रिलेटेड केमिकली। और कोई भी जैसे डायमंड का स्ट्रक्चर पूछ सकते हैं, ग्राफाइट का स्ट्रक्चर पूछ सकते हैं, डिफरेंस पूछ सकते हैं उनमें क्या है। तो XRD, दिस इज अनदर वेरी इंपॉर्टेंट। एक्स-रे डिफ्रैक्शन, उसका प्रिंसिपल क्या है, उसका मतलब वहां से क्रिस्टल मॉर्फोलॉजी कैसे कोरिलेट होता है, एक्सआरडी पीक, एक्सआरडी पीक और आपका जो क्रिस्टल स्ट्रक्चर, इन दोनों में असाइनमेंट कैसे, कोरिलेशन कैसे बनता है कि आपके पास एक एक्सआरडी पीक है और वहां से आप क्रिस्टल स्ट्रक्चर निकाल रहे हैं। ठीक है,
yes, ma'am.
तो ये क्वेश्चन पूछा। ओके, तो
Yes,
आज
ma'am.
का क्लास अभी समाप्त करते हैं, और आप
चलिए.
अच्छे से तैयारी करो, बेसिक्स एंड ग्राफ, and also you have to go and see each and every minute detail
Okay.
while reading. ग्राफ आप चेक कर रहे हो तो इसका एक्स एक्सिस में प्लॉट क्या है, वाई एक्सिस में प्लॉट क्या है, एग्जैक्ट नेचर कैसा है, खुद से भी जैसे पढ़ रहे हो, खुद से भी एक छोटा एक साइड में नोट रखो, उसमें खुद भी ड्रॉ करो एग्जैक्टली जैसे बुक में है, मतलब वो उसको फॉलो करके ड्रॉ करो, सो दैट कि आपका जो फंक्शन है या फिर आपका जो ग्राफ का नेचर है वो चेंज ना हो जाए। फॉर एग्जाम्पल उस फंक्शन का आप जब ग्राफ ड्रॉ कर रहे हो तो काफी सारे छोटे छोटे जो है वो टाइपोग्राफी आ रहा है ना उसमें, तो वो फिर कम हो जाएगा जितना आप प्रैक्टिस करोगे।
Okay.
तो टाइपो एरर आपका कम हो जाएगा, टाइप नहीं मतलब यहाँ पे राइटिंग या ड्राइंग एरर जो भी कहो इसको, तो वो कम हो जाएगा जितना प्रैक्टिस करोगे। ठीक है,
चलिए. ठीक है.
ओके, ठीक है,
ठीक है.
ओके,
थैंक
बाय।
यू, मैम.